Welcome to this video, video 10. In this video, we are going to discuss fundamental concepts in the relational data model and the properties of a table. We are in session 7. So a relation, also known as a table or file, is a subset of the Cartesian product of a list of domains characterized by name. So quite often a table is an actor or an entity within the enterprise. And within a table, each row represents a group of related data values. So a row or a record, also known as a tuple or an instance, that if you're familiar at all with a spreadsheet, an Excel spreadsheet or any type of a spreadsheet, you're familiar with a table. You have the rows and you have columns. Columns in a table are a field, or also known as a field, and are often referred to as an attribute. So it's some kind of additional data that describes that entity. And you can also think of it in this way: an attribute is used to define the record, and a record contains a set of attributes. So the properties of a table has a name that's distinct from all other tables in the database. It's some kind of an entity in the enterprise, so we can't have duplicates of those entities. We would group those together if that were the case. There are no duplicates within each row. Each row is distinct, or each record is distinct. Why would we have duplicate rows? That wouldn't really add anything to the data model or to the enterprise. Entries in columns are atomic, meaning they can't be broken down any further. The table does not contain any repeating groups or multi-valued attributes. If we need to add other attributes, we add other columns. Entries from columns are from the same domain based on their data type, including numeric, and with this we could have integers, floating, small ints, large ints, character, meaning a string, date, or some kind of Boolean or logical, true or false. So these are all the data types, and there can be others that appear in a column, and every column has its own distinct data type that goes for every record. Operations combining different data types are not allowed. However, there are data conversion functions. Each attribute has its own distinct name. The sequence of columns is insignificant, meaning the order that they are built in is insignificant, because they can be brought back in a query in any order the user needs or the application needs. Also, the sequence of rows is insignificant. Rows can be sorted in any way that the application or that the user needs. And some key terms. Atomic value: each value in the domain is indivisible as far as the relational model is concerned. Attribute is a principal storage unit in the database and helps to describe the data in the table. A column contains attribute data. Degree: the number of attributes in the table. Domain is the original sets of atomic values used to model the data, a set of acceptable values that a column is allowed to contain. A field also is an attribute, and a record is an instance, and it contains all the fields for that table. And all records are unique. Welcome back to this video. This is video number 11 of our course, Introduction to Database Design. We are starting session 8. In session 8, we will discuss entities, entity sets, and entity types, kinds of entities, attributes and types of attributes, keys and types of keys, nulls, and relationships and relationship types. So in ER modeling, it's based on two specific concepts. So entities. Entities are real-world objects, usually nouns. There could be exceptions to that. They will ultimately define the tables that hold the specific information for our database. Relationships are defined as the associations or the interaction between the entities. So Let's discuss entities, entity sets, and entity types. So an entity is an object in the real world with an independent existence that can be differentiated from other objects. An entity might be an object with a physical existence, such as a lecturer, a student, a car, or an object with a conceptual existence, such as a course, a job, or a position. You can think of them as tangible and intangible. Entities can be classified by their strength. An entity is considered weak if there is a dependent upon some other type of existence. That is, the entity cannot exist without a relationship to another entity. Its primary key, again, that is the attribute that makes a record unique. The primary key is derived from some kind of a parent entity. So take, for example, the spouse table in a database. The spouse table in a company database is a weak entity because its primary key is dependent upon the company employee or the employee table. Without a correspondence to the employee record, the spouse record would not exist. An entity is considered strong if it can exist apart from all its related entities. Kernels are strong entities. A table without a foreign key or a table that contains a foreign key that can contain nulls is considered a strong entity. Another term to know is entity type, which defines a collection of similar entities. And again, a foreign key is a primary key from another table that exists in a table, and it is actually a link to another table. So we don't have to duplicate the data from the other table. Another term to know is entity type, which defines a collection of similar entities. An entity set is a collection of entities of an entity type at a particular point in time. In an entity relationship diagram, an entity type is represented by a name on a box. So an ER diagram captures all of our entities and their relationships, so we can validate the business process for the application we're building or the value stream we are trying to automate, or just in our database reports. It basically validates that we have the data that we need. Welcome back to this video. This is video 12. We are still in session 8. In this video, we will discuss kinds of entities. So you should be familiar with different kinds of entities, including independent entities, dependent entities, and characteristic entities. So independent entities, also referred to as kernels, are the backbone of the database. They are what other tables are based on. Kernels have the following characteristics. They are the building blocks of a database. The primary key may be simple or composite. So meaning here the primary key is one attribute. A composite is the primary key is literally two or more attributes. The primary key is not a foreign key, so that primary key is not a link back to another table. And the independent entities do not depend on any other entity for their existence. Dependent entities, also referred to as derived entities, depend on other tables for their meaning. These are entities that have the following characteristics. Dependent entities are used to connect two kernels together. They are said to be existence dependent with two or more tables. Many-to-many relationships become associative tables with at least two foreign keys. They may contain other attributes. The foreign key identifies each associated table. And there are three options for the primary key. Again, a composite of foreign keys of associated tables, if unique, and right there that's telling you that there is a dependency or a link to another table. Use a composite of foreign keys and a qualifying column. Create a new simple primary key. Now, none of these are bad practice at all. It's just simply a way to define or associate your entities. For whatever reason, it may be a good practice to understand which are the dependent entities and understand those dependent entities when you are validating your data. But this is not at all to say that dependent entities are in any way bad. you need to model your enterprise as it is. And characteristic entities. So characteristic entities provide more information about another table. These entities have the following characteristics. They represent multi-valued attributes, so they're columns with multi-value attributes. They describe other entities. They have typically a one-to-many relationship. The foreign key is used to further qualify the characterized table. And primary key options are as follows. Again, a composite foreign key plus a qualifying column. Create a new simple primary key in the company database. These might include employee with employee ID as the primary key, and here are the other attributes. Employee phone, and notice here we have employee ID and phone. EID is part of a composite primary key here, so these two together denote the primary key. And here, notice that the EID is also pointing back, or a link back, to the employee table. So we can get the phone information, but we can also get name, address, age. There's no need to reproduce the data from employee in employee phone. Welcome back to this video. This is video 13 of our course, Introduction to Database Design. We are still in session 8. In this video, we are going to discuss attributes and types of attributes. So an attribute, sometimes it's referred to as metadata. It's additional data about a particular entity. It could be maybe for a customer table, could be customer address. That would be an attribute. There are simple attributes, and customer address may be a simple attribute. It's just one column. Then there are composite attributes. That's where we take two or more columns and combine them together for some kind of search or uniqueness. There are also multi-valued attributes. That would be in the case, say, selling in world markets. Many markets can be true at one time. There can be a North American market, European market, Asian market, and all of those attributes could be true at any given time. And then there are derived attributes, and that could be, an example of that could be converting temperature from degrees Fahrenheit to degrees Celsius. Welcome back to this video. This is video 14. We are still in session 8. In this video, we will discuss keys and types of keys. So a candidate key is a key in a database, an attribute that can define uniqueness. It is not a primary key. The best types of candidate keys are not repeated, but they certainly can. And a table can have more than one candidate key. A composite key and candidate keys could be related, and often are, because when we define a composite key, we are essentially enforcing uniqueness with two or more columns or two or more keys. So we could have customer number and name together make a unique record. A primary key, whether it's composite or whether it's just singular or a simple key, does enforce uniqueness for that record. An alternate key, similar to a candidate key, also can define uniqueness, usually with in a composite type of arrangement. And again, tables can have more than one alternate key. And a foreign key is the primary key from another table that's in our table, and it's a link back to that other table. It can be used to bring in data from that other table, and it saves us from having to duplicate the data in a table, and obviously maintaining that duplicate data. Duplicates are always overhead type of work, and it can be missed. Welcome back. This is video 15 of our course, Introduction to Database Design. We are still in session 8, and in this video we are going to discuss nulls in the database. So a null is a special symbol. It's independent of a data type. It means an unknown or inapplicable. It is not zero, blank, or white space. It means no data entry. Very important. So it's different from zero. It's different from white space. Sometimes white space can be accidentally or incorrectly referenced as null. That's not the case. There's white space entered into a record. The data there is white space. It is not null. Definitely means no data entry, not permitted for a primary key. Obviously, a null can not enforce uniqueness. It should be avoided in other attributes. If we model our data and we need this data, chances are we should get the data, but if it is truly null, then that's fine. It can represent an unknown attribute value, a known but missing attribute value, again, a not applicable condition, and it certainly can create some problems with mathematical functions such as count, average, and sum. So be very careful when you're using these functions. And it can create logical problems when relational tables are linked. So beware of nulls. They are a fact of life, but they can cause issues in a database. So just understand what data is null and do your best to eliminate as many null fields as possible. Some examples here. So we are running this query and we're saying select all the employee numbers from the salary table where the job name column equals sales and commission is greater than 30,000. Now we don't see the result set here, so it'll depend greatly on how the database is designed, but we got two records back, employee number E10 and E12. Doesn't mean though there are not nulls though. So anytime you have a greater than, it is certainly increases the possibility we can get nulls back. Same as down here. It looks like our results here are also came back. But then again, we have our greater than. Typically greater than, less than, those are operators that could increase our chances to bring back records that have null columns or null attributes in them. Again, there's nothing wrong with it, but that there's data that's not there, and data is always useful in business. Welcome back. This is video 16 of our course, Introduction to Database Design. We are still in session 8. In this video, we are going to discuss relationships and types of relationships. So entities and tables do relate with one another. There is the one-to-many relationship and also a one-to-one relationship between entities. So here are some examples here. We can see a one-to-one where in this case there's a customer ID and an order, and one customer ID has one order and the order has one customer ID. But then there is the one-to-many relationship where one customer ID can have many order IDs, but every order ID just has one customer ID. There's also a many-to-many relationship. That is where we have a join table and a foreign key is involved. So we can see here how the many-to-many manifests itself. A urinary relationship is when it's recursive. It's when a foreign key refers back to its own primary key, or there is a foreign key that references the primary key of the same table. And ternary key is when there are three entities involved. And we see that a lot when we're talking about a good example are schools. So we could have a course with many courses, and teachers can teach many courses, and courses can have many teachers. And the subject of these courses, a course can have many subjects, and teachers can teach many subjects. So these are the special relationships between the table. Again, we determine this really through modeling our enterprise. We collaborate, or somehow we just know the enterprise, and then we're able to identify the relationships between the tables. And in pointing out things like many to many, then we will know if we will need to relate tables, so we'll know specifically if foreign keys are needed. That is one of the advantages to identifying the relationship between entities.